Hello students, మనం ప్రీవియస్ క్లాస్లో స్టేబిలిటీ ఫర్ ఎల్టీఐ సిస్టమ్స్ అనేది స్టార్ట్ చేసాం కదా టాపిక్. సో ఇప్పుడు అది కంటిన్యూ చేద్దాం. స్టేబిలిటీ ఫర్ ఎల్టీఐ సిస్టమ్స్. స్టేబిలిటీ ఫర్ ఎల్టీఐ సిస్టమ్స్. Okay, a system is said to be stable if it produces a bounded output for a bounded input. With this thing we already know that means if a system, let us consider a system, if a system produces a bounded output, okay, for a bounded input. If it produces a bounded output for a bounded input, then the system is said to be stable. I already told you that what is a bounded output and bounded input in the previous class. Now we shall derive a condition on impulse response that guarantees the stability of an LTI system. Okay, so by looking at the impulse response, that means impulse response h of n, we would be able to say that whether the system is stable or unstable. Okay, for that purpose we shall use the convolution sum. So that means output y of n is equals to x of n convolved with h of n, or y of n, this thing we already know that y of n is equals to h of n convolved with x of n. Okay, so taking modulus on both sides, modulus of y of n is equals to modulus of h of n convolved with x of n. Modulus of y of n is equals to modulus of h of n convolved with x of n. So this is, as we already know that the expansion of the modulus of y of n is equals to modulus of summation, it's a convolution sum, k is equals to minus infinite to infinite h of k x of n minus k. So this is the convolution sum which we already derived earlier. So we, from the basic properties of modulus, so modulus of x plus y is less than or equals to modulus of x plus modulus of y. So from basic modulus properties of modulus, we can say that modulus of y of n can be written as less than or equals to, so that means modulus of k is equals to minus infinite to h of k x of n minus k can be written as summation k is equals to minus infinite to infinite modulus of h of k modulus of x of n minus k, modulus of x of n minus k. Okay, and if you assume that the input is bounded, that means modulus of x of n less than or equals to bx less than infinity, then modulus of x of n minus k is also less than or equals to bx. Why? Because even though if you shift the signal where x of n minus k is nothing but a k samples, this shift, so even though if you shift the signal, there will be no change in the boundingness. Okay, so that's why, so modulus of y of n is less than or equals to bx summation k is equals to minus infinite to infinite modulus of h of k, modulus of h of k. Okay, from the above equation we can say that if the impulse response, this one, if the impulse response is absolutely summable, we can say that the y of n is bounded in magnitude. Okay, if this is not infinity, then modulus of y of n is also bounded in magnitude, hence the system is stable. That means when can we say that this should not go to infinity? If this goes to infinity and this goes to infinity, okay, if this goes to infinity, the system becomes unbounded. So the response, the summation k is equals to minus infinite to infinite modulus of h of k. The condition is summation k is equals to minus infinite to infinite modulus of h of k should be less than infinity. If this is less than infinity, so we can say the system is stable. This is a condition on impulse response for the stability. Okay, so the same concept can be extended to the continuous time LTI systems. That means y of t, where y of t is equals to h of t convolved with x of t. So y of t is equals to modulus of y of t is equals to modulus of integral minus infinity to infinity h of tau x of t minus tau d tau. Okay, and we can say that this is less than or equals to integral minus infinite to infinite modulus of h of tau modulus of x of t minus tau d tau. Okay, so this is less than or equals to, let me write this as bx integral minus infinite to infinite modulus of h of tau d tau. Okay, and this bx is modulus of x of t minus tau d tau, which is a bounded signal. Okay, the input is a bounded signal. If the input is bounded signal, that can be replaced with the bx. And the next thing is, this must be less than infinity. If this is less than infinity, and if this is less than infinity, then y of t becomes a bounded signal. Okay, a bounded output. If this goes to infinity and y of t becomes unbounded. Okay, so for a system to be stable, the condition on impulse response should be finally this one, integral minus infinite to infinity modulus of h of tau d tau should be less than infinity. This is for continuous time LTI systems. Okay.